Hello everyone. In this video we will study a generalization of one of the properties for probability tree, or one of the rules that we can use to find probabilities of events on a tree. Well, recall that to find probability of an event which is on a node of a tree, what we did was that we find sum of probability of all paths with ends to E. So we find all paths which end to E. We find probability of each path, which is product of the numbers along the way, and then add them. Now, what about probability of to find probability of intersections? So you have several events. You want to find probability of intersection when you have a tree for that stochastic process. In that case, you again find all paths that include all of those events. So you first find all those paths. Find the probability of those ones, which is for each path you multiply all the numbers along the way to the root. Then you add those ones. That will be probability of intersection. Similarly, you can have a probability of a union. Again, this time, you have to find all the paths which include either of those events. So union comes with or, intersection is and. So we first need to find paths that include, include either of the events. Okay, then find probability of those paths, and then you add them. So if you do these things, basically everything boils down to find the right paths. For intersection, you find all paths which includes all of these events. For union, you find paths which includes either of those ones. Okay, let's see this in some examples. We have probability tree here. We are trying to find a probability, for example, probability of A intersection B intersection C complement. So I need to find a path which includes A and B and C complement. Here you see A, B, and C complement. So this is the only path which we have. Well, we already knew this thing based on the fact that we learned in the first unit the probability of intersections. If a path, you consider a path which includes A, B, C complement, and then multiply entries on that, it will give you the probability of intersection. So this is going to be 1 over 20. Okay, how about, okay, so I have the tree here also, so that if we need, we can. Probability of A complement and C. So we have to find all paths which includes A complement, so it will go from here, and C. So this will be 1, this will be the second one. So here basically we are looking at these two paths that are here. Okay, so in that case we are looking for probability of the first path is 1/3 times, so I'm going this way, 1/3 times 1/2 times 3/5. The second path is, this is what is going on, 1/6 times 1/2 times 3/5. And then simplify the numbers. While here this goes with that, this goes with that. And then what we get is, the first one is 1/10. The second one is 1/20. That will give me 3/20. What about probability of A intersect B complement? Well, in that case, we are looking for all the paths which includes A and B complement. Here is an interesting thing. You can either go and look for all the paths, so you can say that this one and B complement, this one and this one. But there is also a nicer way to see this, that you actually don't need to consider all the way up to the end. The only thing you need to consider, because if you cut your tree from here, so let me say, cut this from here, that is a probability tree itself. And you can use the rule there, and in that case you see that there is only one item there. So this will be the same thing as, so 1 times 3/4 times 2/5 plus 0 times 3/4 times 2/5. So both of them will give you the same number, but if you want, you don't need to go all the way to the end. So you can cut your tree from a point on and then look for the paths that ends to those events. Okay? Well, okay, so let's just then compute these probabilities. This will cancel with that. That is 3/10, and the second one is 0. And the last example is probability of A or B. Okay, so in that case, if you look at the tree, you see that, okay, there is this path which includes A. This path includes A. This one includes A, although it doesn't include B, C. And this path will include A as well. And now, if you go down, you see that there's one path here, and I'm looking for B. Okay, and these two also include B. Well, since it's union, we are interested only on either. Yes, so or either A or B. It can include both of them, and that's what we are. So now we have to find that, we have to use all those probability of all those ones. So this will be the fifth one, fifth one, fifth. Oh, this is fourth, sorry. Okay, all of them are given that same number. The interesting thing is that, well, if you want to do all those ones, this is going to be half times 1/4 times 2/5 plus half times 1/4 times 2/5, then times plus 1 times 3/4 times 2/5 plus 0 times 3/5 times 2/5. So all these are the fourth the first 4. Then there are the last 2, which is 1/3 times 1/2 times 3/5 plus 2/3 times 1/2 times 3/5. But to be honest, we could have cut this tree from here as we did for the previous one. In that case, instead of computing 6 numbers, we would need only compute this 4 or 3 numbers. So in that case, it will be 1/4 times 2/5 times plus 3/4 times 2/5 plus 1/2 times 3/5. And while the computation, if you do the computation, complete the computation. I guess I put one of these numbers wrong. Yeah, this must be 4. Yeah. So if you do that one, these two together will give us 2/5 plus this one here is giving us 3/10. Well, that means that we have 10, 4 plus 3, which is 7/10. And you see that sometimes if the events you're looking for doesn't go all the way to the end, you just cut the tree from the level that these events end, and you consider that smaller tree to make the computations easier.